Can the people who want to hear? Is the talking too loud? Slightly too loud? Okay, if you guys can't hear at any point, please raise your hand, because it really is a waste if you guys can't hear. Okay, cool. Before we get into it, I just want to do a really quick disclaimer. These are questions by Tarun. And I was like, Tarun, give me your best account abstraction questions, and I'll moderate, because I want you to be able to answer the questions and bring your brain juiciness to the crowd. So that's just the disclosure. All right, before we get started, maybe can we do a quick round of intros, your name, the project that you work on, and maybe we can start with Tarun.
Hey, I'm Tarun. Sorry for being late at Gauntlet, and yeah, great to see you.
Hello. Hey, I'm Will, Element Finance. We will be Delve here shortly, will be the new name. Yeah, good to meet you all.
Hey y'all, my name is Ryan Sproul. I work at Blockchain Capital, and I also here am talking about a little bit of the fuel stuff, because I've worked on that quite a lot. So yeah, glad to be here.
Hi all, my name is Alex, and I'm co-founder of zkSync.
Did you guys hear that well? Okay, cool. All right, first question. There's been a ton of panels and a ton of talks about account abstraction at ETHDenver. I feel like in the last 3 months, it's really become a hot topic. So I think we have a lot of content out there, a lot of talks out there, but really quickly, could each of the panelists explain maybe account abstraction, explain it like I'm 5, but the challenge is, like, don't talk about EOAs and don't talk about smart contracts. That's getting into the weeds. At a high level, explain it like I'm 5. Anyone can go ahead and take the question.
Well, I can try to begin. So account abstraction is when you have an account with some code, with some logic. You can program it, like your wallet becomes programmable.
5-year-olds know what ECDSA is, right? No, I mean, like, account abstraction just generally is a way to decouple the protocol level, like authentication and authorization, via some sort of smart contract code.
Hello. Yeah, so basically current transactions that go through Ethereum, they have this thing called a nonce, which sort of orders by your account. I don't know if we weren't supposed to use the word account. And it also does an ECDSA signature check. So those are essentially these early validation requirements that these nodes do to make sure your transaction is good. So account abstraction, what it does is it lets you customize that. You can add different signature schemes. You can, essentially have a contract, a wallet, pay for your gas. You could do, multi-threshold signatures from a DAO, where a DAO can essentially have validation when they sign something together as well. So there's a lot of really, really cool use cases this introduces. Yeah, that would be my quick explainer.
Well, that is a very smart 5-year-old, clearly. But I think I would just say, when you get your allowance as a 5-year-old, normally you have to go spend it yourself. But you could think of account abstraction as a way of allowing others to help you spend your money.
Okay,
That was a 5. I was trying to find the actual 5-year-old.
No, you follow the prompt, but you can go ahead and add on if you want to.
Yeah.
Okay, cool. Before actually getting into your second question, I want us to talk about 4337 as it relates to Ethereum, but I also want Ryan to talk about how Fuel implements account abstraction, because a lot of the conversations around account abstraction are framed around 4337, and rightfully so. We're here at ETHDenver. And I think one thing that gets left out a lot is that there's other teams out there, other projects out there that implement account abstraction in different ways. So maybe first, can whoever feels comfortable taking the question, can you at a high level explain what 4337 proposes? And then Ryan, can you talk about how Fuel implements account abstraction?
I can tell you about 2938. But the latest version, the best way that I would put it is you essentially have a separate mempool. And this alternative mempool relies on relayers that essentially validate this set of transactions ahead of time for you, package them up, and send them to a contract that's on chain. This is interesting because it's you don't have to have major protocol updates or major protocol changes. Before in 2938, we sort of had to build this into, our geth nodes, and we had to add, pay-gas opcode and a number of other things. And so essentially, this is really cool for one reason. This new model is it introduces the infrastructure that we really, really need. The relayer paradigm is sort of what I call this. Has been, in discussion in, ETH research communities for quite a while. But it doesn't just enable things like this infrastructure, things like account abstraction. It also enables things, down the road. If you think about different, app chains, different roll-ups, different L2s could sort of buy into this sort of space of relayers that optimizes for transactions across their sets. And it's actually an interesting way to get along, get to the route of having cross roll-up, synchrony in some ways as well, which I think is really, really cool. It introduces that possibility. Some of the sort of issues before that we had was, there's DOS vectors, and this is why it's, really important, and it's really cool to sort of make this separate. And it's, essentially have a separation of concerns.
I think the only thing I would also add is, there's a lot of different attack vectors that come with having the relayers, whether it's denial of service or whether it's particular relays don't have certain guarantees. So designing the system is actually a bit complicated. Potentially has to have some changes to, some of the proposals have had changes to opcodes, and a lot of the differences in the proposals differ in which extra opcodes they want to add.
Yeah, I can say. One of the things, by the way, this is interesting. So when we were originally looking at this, we created a tool called Bazooka, which was, we created this tool called Bazooka, and Bazooka is essentially a tool to take down the ETH network. And we used this to see, can we DOS account abstraction? Can we DOS these nodes? Can we make vectors where we're taking down nodes that are sort of running account abstraction, on them? We actually showed that there are DOS vulnerabilities. The DOS vulnerabilities aren't insane, actually. There's a lot of mitigating efforts that you can do to fix that across the wire protocol, how they sort of speak to each other. So like Tarun said, it's super important to sort of think of that aspect and sort of how to make sure that you don't have these denial of service issues.
I also think it's worth taking a second to just describe what these DOS vulnerabilities are. Why is this a problem in the first place? So why do we have gas on blockchains? It's a user requests some sort of compute or resource from a node, and you need to be able to make sure that node is being compensated for such expenditure of resource. So account abstraction, if you just inject a place where you can execute arbitrary code without necessarily having a gas or payment of gas at that place, this is where the DOS vector kind of shows up, especially on the chain. Relayers is slightly different because it's not in protocol, but it's still a place where you can get have a denial of service attack. So yeah, that's kind of why this is not super trivial to build. And then also just for the existence of ER34337, or why account abstraction is so complicated on ETH is because of backwards compatibility issues, and just integrating stuff into an existing protocol that's been operating for several years is not super trivial. So opportunities like new rollups or layer 2s that can add protocol level changes from the start have an advantage there. And specifically Fuel they designed this thing called a predicate, which is different than account abstraction, but it achieves the similar goals, where you can have arbitrary code execute to allow authentication or authorization of spending of coins, which is really at the end of the day what you're trying to do. So you could put this stuff in protocol with something like Fuel and account for these DOS vectors in kind of a unique way. So you have to be able to make sure that the request, the transaction that the user sends, either can be blacklisted if it's intentionally malicious, so it needs to be provably malicious, or it needs to actually spend gas. So Fuel basically makes sure that every transaction is certainly malicious or not, they can prove so by not letting you touch state and kind of putting a bunch of limitations around it there as well. And I guess we can talk more about how 4337 kind of does similar things, but I'll let you guys do that.
So I'm just gonna add that at zkSync we are also following the approach of integrating the account abstraction directly in the protocol. We are not having the limitations of Ethereum and legacy code, and this is a great thing. And we believe that the L2s are the place where the experimentation has to take place, and then like potentially be merged up in the layer 1. And we should not wait for layer 1 to innovate. Like it's the job of L2s. But we're actually following the EP 4337 very closely. Like we try to do as little changes as possible, just to avoid the points of centralization, but actually make it a part of the protocol, so that it later can be upmerged into Ethereum. And we're coordinating really tightly with the Ethereum Foundation, with the researchers there, to make a community effort to keep the standard as close between different chains as possible.
So there's a number of new roles in the lifecycle of a transaction: a user mempool, a bundler, and a pin singleton contract that more or less precompiles. This introduces a lot of extra surface area for DOS and bugs. Which particular attack vectors stand out to you and why? Maybe you can start since you wrote this question.
Well, I think we actually did just talk about that.
But we didn't specifically talk about which specific bugs and DOS vectors. Like what specific ones stand out?
I think for me, yeah, the relay incentivization is actually quite a potentially big issue if people are able to keep the relayers offline if there's a small number of relayers, and your transaction in yours kind of late confirmation. There's a lot of stuff like that especially if people are submitting sort of predictable bundles, people front running them, a lot of like weird sorts of MEV around the relayers that are kind of where the incentive pieces get very complicated. A little bit different than kind of the stuff that you're talking about, which you can.
Yeah, I do have a question, actually, for y'all, or for you specifically, or anyone. Essentially, on the relayers, do you think that would end up getting merged anyways with like the core nodes in the network, or is there sort of some type of scheme that essentially ensures that they might be separate?
Well, I mean, it sounds like the Fuel version already does that. I think in Ethereum, it's just harder to convince people to make such a large change, which is to the point of like the L2s are going to innovate on adding this directly first before Ethereum.
But I mean, a lot of the same arguments apply to the bundler role as like we have in MEV like builders today. So it's like a lot of these are being explored, and like the vulnerabilities exist in somewhat like as they do today. Like it's like a builder or a bundler can do some sort of censorship. Like that's basically the extent of their like the attack really here. So if there's a way to finalize the transaction by skipping the bundler or skipping the builder, which is possible. Like you can just talk directly to a node, which is basically what you could do today in the builder world. So I don't see that as like being the biggest vulnerability. Sure, like we could talk about like the smart contract code being like implemented incorrectly, like actually having bugs in that place. That's like relatively interesting, but like these are not the most complicated contracts, so I don't see them being like the most high vulnerability area. So yeah.
Yeah, and just to explain the DOS vector a little bit, so let's say contract B, in its validation, okay, says if Uniswap has had, I'll just make up something arbitrary. There's a new Uniswap. If Uniswap has had, this, let's say, current Oracle price approved, right? And then someone comes in and they do a swap on Uniswap, they change the price. And if you have these validation requirements that rely on sort of external state, right? The DOS issue and this is sort of the major thing, the DOS issue that comes into play is all your transactions that sort of point to that state become invalidated and they need to run again. So you sort of end up getting this like interdependent system. And this is sort of the crux, the core of the DOS vulnerability. There's a lot of interesting ways. I think Fuel, for example, with the predicates and sort of their approach in a more UTXO format and having basically state be centered around your contract, to my understanding, actually makes it a lot easier, right? It's a lot more defensible from that aspect because it's very clear what variables, what state, what values, what things you're pointing to in this world when you're doing these validations. So.
Yeah, I mean, in predicates, like you just straight up can't access global state for this exact reason, and it's coming back to the like attributability of it. Like, can you prove that this was a malicious attempted transaction? And if underneath, like you have a predicate that relies on some sort of state that can flip to make the transaction valid, invalid, valid, invalid, and flip back and forth, then you can't prove that it was an intentionally malicious transaction, so you can't block this user in the P2P network. So yeah, that's kind of the core reasoning behind that.
So I think in a lot of the conversations about account abstraction, it's like centered around and hailed as, oh, this is going to improve UX, this is going to do a lot for the UX. And I think in all of the writing, at least that I've read, and in all of the conversations that I've heard, the like really concrete examples that we hear about, or at least that I've heard about, have been things like having like a Web 2 like login where you don't need a wallet, social recovery of wallets, native multi-sigs. Those are like really the 3 core examples that I've heard. Is it fair to say, like, for example, I talked to James Presswich about this when I was researching to write my post that I did, and I asked him, like, what concretely will we be able to do with account abstraction that we are not able to do now? Like, very concretely. And he was like, honestly, like, a lot of it we just don't know at this phase. Is that a fair statement that a lot of the UX improvements that can come at this time really are unknown?
Well, it's a completely valid statement with that we don't know a lot at this at this point. It is also a valid statement that we know a lot, right? So like what we know is the cases you brought. I mean, if you just think through the user experience of like first interaction with a wallet, where you have to bother with the secret phrase, and they tell you to store it safely somewhere, and then you have to buy some ether to pay the gas, and so you cannot just get some like tokens from someone and start paying these tokens. So like lots of friction points that just like hinder adoption overall. But really interesting things that you can do with account abstraction is lowering this longer tail risks for the users. So for example, you could introduce daily spend limits, and you can say like any transaction above certain threshold, I want to authorize it with a second factor with an additional key. So this way you can guarantee that like if users are going to be interacting with contracts, they will not run into something where they do one click and it's a wrong transaction, they get all the money lost. But you actually have to redesign other protocols. Like think of ERC20. In order to make a Uniswap trade, for example, with like 2 ERC20 tokens, you would, or like even if you have to send 1 token and get something else back, you first have to approve transaction on the smart contract that like on the swap contract, and then you have to do the second call to actually execute the transaction, because the standard doesn't allow you. Like in Ethereum with EOAs, you cannot do a multi-call natively. You cannot do one single transaction that accomplishes multiple things, which are critical for user experience. So in order to improve slightly user experience, users are going for like approving all of completely like blindly trusting this contract, which introduces risks, and we've heard of a lot of people being rocked. So like this interplay between the UX and security is where account abstraction is going to really shine. Just one big use case area.
Honestly, I think it's pretty easy to think about what we can do like at the first step, because we know how like banks work and how Web 2 works, and like account abstraction initially will enable like that experience, but the thing is it actually can enable a whole lot more, because unlike if you're using Google OAuth or something to integrate auth into your application, you actually can customize like what the auth conditions are. Like you have access to the smart contracts themselves that define like the auth rules. So like Google is behind the scenes is doing something with, you know, maybe you have to go connect to your YouTube account to prove that you own this thing. Like that's them defining the rules for authentication. Like if you wanted to do it yourself for your application or for your wallet, account abstraction, because the nature of like the open Web3 world, like you can go and deploy your own wallet that does exactly the features you want for your application. So it's kind of first step, get parity with existing solutions like safety around transfer limits like you mentioned, and like your normal authentication flows you're used to in Web 2. But then the step after that is a whole new world of additional things you can do with the programmable auth.
Yeah, I think some like really cool look ahead ways that might make us think of things that we're unsure of yet is, so for example, let's say slippage parameters. When I put in a swap to Uniswap, right? I say, I'm going to make this swap, and I have a 10% sensitivity to a change in price, right? So you could put that as part of the pre-validation requirement. So the transaction goes up there. Instead of you having to pay for gas and getting a revert, that's already situated essentially for you. I think there's also like other really interesting things to look at. So there's DAOs, for example, now sort of have a functional multi-sig wallet that has its own validation requirements that are set by the DAO that sort of code in sort of core rules. And these, there's a number of things you can do. Some other interesting ones are you could have timed transactions. So maybe your transaction's not valid now, but it'll be valid a week from now. And so, and maybe it could poll, right? We call this, it's a concept of polling, where you make a call regularly, or on like a cron job, where you make a call regularly, maybe once a week. You could have basically these transactions in an account abstraction world that become valid suddenly, and they can run, and then they're invalid, and it becomes valid again, and it can run. And so you can actually introduce these sort of timing requirements to your applications. So I think it goes to so many different areas, but it also allows us to experiment with signatures, right? So there's quantum resistant signature schemes. There's a bunch of different things that can be experimented with and tried. Maybe that's useful for a particular mixer that's deployed. Maybe that's useful for a different application. And it allows us to sort of experiment with that. So as far as like what it gives really cool flexibility, and almost in a way is an early precursor to what I call having sort of custom execution logic on a contract by contract basis.
Yeah, I mean, I think the thing I'm most interested in personally is having contracts be able to do MPC between each other. So right now, if you think about the workflow for MPC, if you've ever used an MPC wallet, the MPC, there's a key share that like is off chain that maybe like say like a Fireblocks or Coinbase wallet has. Then you have your own keys. You both have to sign, and then you can generate the transaction. And now imagine if like two DAOs could do MPC together, where they could actually do some computation, and they both sort of are able to do it in a very verifiable way. This type of stuff, I think, has not been really explored with edge cryptography, where contracts actually take advantage of that, not just the end user pushing things. And yeah, I'm not exactly sure what the applications of that look like, but I think a lot more complex financial transactions around, DAO treasuries and things like that are enabled by this.
I think in a lot of the conversations about account abstraction, it's talked about as like a one day or like a theoretical thing. But I think it'd be interesting if you guys could talk, maybe you two specifically, about what are some applications that are live right now that are enabled, either the applications as a whole or have features that are enabled by account abstraction, and how specifically it works. I know, Ryan, you built something with predicates, and I imagine there's some stuff that you can talk about on zkSync.
Sure. So the example that comes to mind first is Argent Wallet, which onboards users with very, very nice, smooth onboarding experience without seed phrases, but it's still fully self-custodial. You keep your keys. It's easy to recover. It's easy to use. You can define the spending limits, the safety logic, etc. So like you don't pay. You can like generally like paying fees in any tokens is a huge use case which is already being leveraged on zkSync, and protocols subsidizing transactions, like protocols paying for transactions, like completely gasless transactions. So all these things are being built right now.
Yeah, I mean, gasless transactions is like pretty awesome first one, like because that just removes that initial first barrier for like getting your user to come use your app. You don't have to go fill a wallet with whatever. But I guess the one project that I've worked on in the past was a predicate-based order book. So each order is defined by like An order book is it's a type of market where people define their orders, which is like a limit order or a stop loss order or whatever. Like it's just a definition of when you want your coins to be traded from one coin to another coin. You know, it's an order that you're defining, like what you want to be transferred. So in this case, it's a predicate that defines, say, hey, I will transfer X tokens to this address if somebody else sends me Y tokens of another type. So you can actually fully build an order book without any state on chain and just fully define each order as a predicate. So it's a somewhat interesting way to have a define user like operations or user preferences without any state. So yeah, that's just like a kind of a fun way to utilize predicates that's kind of not normal account abstraction. Like generally we hear about social recovery and those side of the use cases, but you actually can build full applications that are just leveraging this, like the validate step, you know, this logic that you're running before you execute the transaction.
Yeah, I mean, I don't know about currently, but I was just thinking of another cool use case, which is, let's say I have like a weekly payment I need to do, and I can essentially put those, you know, transactions up ahead of time, and they might not be valid and cross that time threshold now, but they will later. So I think that's actually like a really interesting one. I love like the concept of mixers. You know, you're not having to use ETH in your destination wallet, I think, and not have to go through a relayer. You know, I think that's really, really interesting. But yeah.
Yeah, I think the last thing that I was thinking of is, you know, a contract or a DAO being able to participate in like a signature aggregation group, so like a BLS signature group. So like imagine a DAO has to sign up, like you have a consortium of DAOs that has to sign off on a particular transaction, like, hey, we're like pooling together funds and spending it on this particular public good. Now the DAO members can vote, and then the DAO can actually execute its correct BLS transaction, and the pairing can kind of work correctly. So there's a lot of weird stuff where you start bringing, you know, a lot of times people talk about how like you make EOAs more powerful by giving them programmable functions, but you also actually give contract entities more power too when they have to work together or cooperate with each other. So those types of applications, I think, are things that people haven't really explored yet.
Okay, many of the features account abstraction provides are currently found off-chain, i.e. in MPC wallets like Fireblocks or Coinbase. How do you think these products will change in response to account abstraction?
They would have to embrace it because account abstraction, the difference to it is those are centralized solutions, and we're trying to build something that is fully permissionless and barrierless to everyone to use, and where you control your account. You don't depend on any single party to relay transactions for you, and like this party can censor you. You want to rely on the censorship-resistant properties of the entire network, which is as we want to see as decentralized as possible.
Yeah, I mean, I agree with that, but just in general, like some of the existing MPC solutions, like I don't think they can't coexist with account abstraction. Like account abstraction can kind of achieve all the same things, so maybe it's better eventually. But like today, Fireblocks has very sophisticated like software around how to manage or authenticate a transaction. Like you could still use that like on top of a account abstraction wallet, and I still find that like pretty interesting way to manage like your accounts. And I could see like a lot of ways that they could still work together.
I don't really care about centralized solutions.
Yeah, I kind of am more in the coexist camp. I think they'll actually like embrace it in the sense that they'll redesign a lot of these wallets in the same way that you were talking about Argent redesigning things. I think a lot of the like more custody stuff that people do hot and cold separation for, they'll do a lot less of that. And so we'll see kind of like lukewarm wallets. I don't know what else to call them, but like these wallets that are technically cold wallets but have these rules that get applied at certain times so that like people who store their keys at the bottom of mountains in Switzerland can still use them somehow.
Okay, we have a couple minutes left, and I thought if you guys agree, it might be cool to take a question or two from the audience. Because I think that, like, again, I think this is a really rare opportunity to ask questions to a bunch of experts that you might not necessarily have access to these people normally. So maybe we can take one or two questions. I'll repeat your question, but try to speak it loud. Okay, the question was, what is the ideal kind of implementation of social recovery? And you're saying that the kind of solutions that you've heard of involve, did you say like trusting friends and having additional signers? Is that what you said? Okay, got it. She was saying it's either like on the spectrum of trust your friends to not lose their keys, or trust like some institution or centralized party to manage those for you. So to recap, the question is like, what do you think is the ideal implementation?
Yeah, that's very subjective, but I think there are multiple directions that can be taken to make it really cool. One would be like appointing friends to be your guardians, but not telling them. Only tell them like when when the problem arises. Or you can introduce multiple levels of trust. So you can say like, these people are closest to me. So like they have like just like they can recover in 1 day or after inactivity or after initiation of the recovery process. These guys are a bit further, so I need more of them, and it takes 1 week. And this centralized notaries and like whatnot, they have to take like if it's an inheritance case, it has to take half a year, and like several of them have to do it. Like introducing these grades of trust, for example, like, as one example.
I mean, I generally get it's a very subjective thing. Like, what is ideal for? It's different for every single user. So, like, I think the point is that this gives you the optionality. Like, you can build your own solution, or you could find someone in the market that's providing it for you. And I kind of hope that market forces would end up kind of finding this optimum place. But yeah, I see it as a spectrum. Like, there's a lot of downsides to say having your friend that maybe is your friend now, but not in 6 months. But in general, like giving the optionality is kind of how you allow a market to form here to find a good solution.
Proof of friendship.
Yeah, I actually, so I think the optionality is actually important. As far as onboarding people to crypto, that arc, you probably need a system where there's a trusted entity that people can opt into if they need. I think, it's sort of hard to make the jump suddenly to like, okay, let me get my like mom, father, grandma, cousin, friend, they probably aren't even managing their own wallet well, so I probably don't trust them to do it. And there's only a number of people in this world, that I trust enough, right, to sort of give them access to that as well. Whereas I think, as sort of a transitionary step, if you can opt in and there's a legal recourse, to those parties, is probably the easiest way to onboard it. That being said, having a more decentralized solution around this is optimal, and I think it's sort of the arc of where it will go. It's just not. It's hard to get that right without the mass adoption.
The only thing I'd add to kind of build off Alex's example is one of the weirdest problems in custody, in my mind, is sort of like estate planning, and right now that only happens via centralized custodians, right? Like, if you die, your whatever living will memoriam can go call Coinbase custody or Anchorage or whatever and like get some of your assets back. But you can't do that on chain. But with account abstraction, you actually could do things like that on chain, where like if this wallet doesn't send a transaction for like a year, then like this other delegated wallet is now allowed to remove a certain annuity. There's a lot of stuff like that I think people haven't kind of like, that we rely on the centralized entities for right now, that I think, get to this notion of like recovery. That is a form of recovery, right? If I die and my estate, my, kids or something are supposed to get an annuity. Something to think about also.
All right, maybe one more question. Go ahead.
On an execution layer versus what? Oh, I see what you're saying. So there's a lot of moving parts to get these things working, especially when you do it on something that integrates with Ethereum, because you have to think about how does it affect the economic security of Ethereum. Ultimately, people who are running nodes are probably going to also run relayers, right? There's sort of the support effort and movement to get it forward, to coordinate, basically the whole ecosystem to go forward. That takes time. I have no idea how long this proposal will take. I haven't been as involved in this one, but I know like a lot of times building like a version of it, it's not that hard, right? A lot of times the harder question is, how does this function in pathological cases that can compromise, certain security standards that we might have, and how do we get everyone to sort of support that? That's sort of what a lot of things boil down to. This is why a lot of times it's really, really helpful to introduce new features to smaller chains, smaller L2s, things like that, because you're not steering this massive ship that's holding tons of value in it, right? And yeah, that would be my answer. But I don't know the exact timelines or dates.
Why would you want it on layer 1 anyway if most of the activity is going to go on layer 2? It's like layer 1 is going to be way too expensive to transact. So you want to start with layer 2s which have a future-proof path to real scalability, to bring in millions, 100 millions of users. So what I would recommend is to build it on zkSync, because zkSync is the first live zkVM on mainnet for developers. You can build today and launch it on mainnet today. And the account abstraction is live, and it's going to be open to everyone in some weeks from now. So I just encourage to explore zkSync.
Yeah, and similarly for other L2s, out of the gate, these features are supported and ready to go. For Fuel, predicates are a native part of the language and part of the VM. So yeah, it's been there from the start. And then I just quickly would mention that the whole the whole design philosophy around 4337 is to minimize the amount of changes required on the two ends, so on the protocol level and on the user interaction level. So from a user's perspective, basically nothing can change. You can interact with contracts in the same way. User ops get bundled by this middleware layer, so there's not really much real change going on there. So the experience is relatively simple. Yeah, that's pretty much it.
All right, any closing thoughts, plugs, things you want to show, things you want to shout out? How can people find you? How can people read more about whatever you guys publish? I'm encouraging, I've been trying to get him to write more, and it's been working. I know you have written stuff. You continue to write stuff. I'm not sure about your kind of writing. Do you write a bunch of stuff? Yeah. So where can people find, and then any last minute plugs?
We're on Twitter under zkSync. It was a pleasure to be on the panel, and I sincerely believe that account abstraction is the thing that is going to unlock the next wave, the order of magnitude more users to blockchain systems. Together with scalability that layer 2s provide, this is something that just opens the new era for blockchains.
Agreed. What's the point of scaling L2s if we don't have any more users coming on? So account abstraction is the way to that. And yeah, I guess if you want to read my stuff, I have a Twitter, and check out the Ethereum Postal Service.
Twitter as well. I post on a lot of different things. And yeah, posted in the past on ETH Research, a bunch of different forums. We are launching actually a few different papers here soon that are coming on some new AMM models, some other things. So stay tuned for that. I want to say regarding account abstraction, one of the reasons why I worked on it and was so excited about it was because it sort of saw a glimpse initially this concept, which is complete arbitrary execution. This is this concept called execution environments, where each contract can sort of define its own logic, functions, that's not necessarily just EVM, right? And I sort of saw account abstraction as an early stepping stone into that world. I think that's sort of the world that will come to fruition, and these are the early steps that get us there, which is really, really cool. So I'm really excited that things are moving forward and that this is coming to fruition.
Yeah, hey, Twitter, or just look for the person wearing too many colors. And I'm giving a talk on Saturday at ETHDenver about cross-chain MEV auctions. So that's my shill.
Okay, cool. Thanks, everyone.
Thank you.